Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. When ML teams try to run complex workflows through traditional orchestration tools, they hit walls. Cash App discovered this with their fraud detection models. They needed flexible compute, isolated environments, and seamless data exchange between workflows, but their existing tools couldn't deliver. That's why Cash App relies on Prefect. Now their ML workflows run on whatever infrastructure each model needs across Google Cloud, AWS, and Databricks. Custom packages stay isolated. Model outputs flow seamlessly between workflows. Companies like Whoop and 1Password also trust Prefect for their critical workflows, but Prefect didn't stop there. They just launched FastMCP, production-ready infrastructure for AI tools. You get Prefect's orchestration plus instant OAuth, serverless scaling, and blazing fast Python execution. Deploy your AI tools once, connect to Claude, Cursor, or any MCP client. No more building auth flows or managing servers. Prefect orchestrates your ML pipeline. FastMCP handles your AI tool infrastructure. See what Prefect and FastMCP can do for your AI workflows at aiengineeringpodcast.com/prefect today. Your host is Tobias Macy, and today I'm interviewing Andrew Filev about the system design and integration strategies behind building coding agents at ZenCoder. So, Andrew, can you start by introducing yourself?
Hey Tobias, hey audience. Andrew Filev here, CEO and founder at ZenCoder. We build awesome coding agents. And prior to that, I was building a company called Rike. We co-created a collaborative work management space. I grew that business to about 1,200 employees, so about 300 people in my engineering organization. So things from zero to full scale. And then I've been around the block in AI for a while as well. I like to say that my introduction to agents was when I ran our hobby team trying to compete in DARPA Robotics Challenge about a decade ago. So there's a little bit different agents that I'm working on today and a little bit ahead of time, but that was super fun. So that's a bit about me.
And do you remember how you first got started working in the ML and AI space?
So I can go back to kind of my teenage years in sci-fi and cyberpunk and like reading about brain-computer interfaces and kind of getting all excited. And then kind of as the years progressed, I was always interested in neuroscience and what I would call cognitive computing, which sort of like one, you can think AI is like one incarnation of it, right? But it's either about how do we make computers smarter or how do we understand and replicate our own brain's work. So I think where it kicked into higher gear, if you remember, like the very, very, very first wave of online, like massive online classes by Andrew Ng and then by Sebastian Tran and whatnot. And so that was when I got the first kind of a good early lightweight education in kind of more formal, and that really piqued my interest. And then I started filling my bookshelf with books about pattern recognition and computer vision and all of that good stuff. So again, more than a decade ago right now.
And so now digging into your current area of focus, which is generative AI and its application to software engineering and automation around that. Before we get too deep into some of the specifics, I just want to give a bit of a sort of survey overview of where we've been and where we're going. And over the past 3 years since ChatGPT first hit the scenes, there have been a few different iterations of how to apply these generative AI models and LLMs specifically to the problem of software engineering, with the first pass at that most notably being GitHub's Copilot of a more intelligent autocomplete. And obviously, we're well beyond that now. And I'm wondering if you can just give your characterization of the different approaches or categories of generative AI as a software engineering aid.
Mm-hmm. Yeah, great question. And I'll skip kind of the prelude because even before Copilot, there were some tools like Kite and whatnot. And even before that, there was IntelliSense. So we'll kind of glance over it and go more into sort of GPT-4 era, if you will, right? So you're correct. It started with code completion, and Copilot back then was the big story, and there was a lot of buzz around it, both positive and negative, right? There were like claims that it can improve productivity by 30%. There was also anti-hype claims that everything is going sideways and the code is going to be terrible and whatnot. So like looking backwards, it's some of that stuff on both of their kind of their hype and anti-hype side of things are a little bit funny these days. But anyways, if when we look at the underlying models back then, it was what I would call at best GPT-4 class models that were wonderful in a lot of things that they did, but they were also pretty terrible. So when we got into this, we did some things that right now they look obvious, right? But they didn't exist in the category. For example, when models try to apply edits, they messed up stuff. And even before that, when models generated code, more often than not, that code did not compile and was kind of heavily hallucinated. So we started by taking kind of their very, very basic agentic behavior, analyzing syntax of the code, and then if it was wrong, trying to give the feedback to LLM and kind of cycle through the suggestions, if you will. And so that was their first gen. And then in that first generation, because the models were not trained for truly agentic behavior, you had to feed information to them. And so finding the right information was critical. So when we got into this space again, we focused very heavily on building state-of-the-art code RAG, and we built our own custom re-ranking pipelines, which are even more important than the retrieval itself. The ranking is a much harder and more consequential problem. But anyways, that's their Gen 1. And while we and others were working on Gen 1, something landed on everybody's lap. It was Sonnet 3.5. And it changed the game significantly because it was the first truly agentic model. For example, it made, for simpler repositories, it made the RAG obsolete because the model could actually find more relevant information. And because it was trained that way, it was also kind of in distribution. So it worked better on the information that it discovered. And while it discovered that information, it also picked on subtle signals. For example, if the model browses your directory structure, typically that directory structure in itself brings valuable information about how you sort of divide and conquer, how you architect your solution essentially, right? That is very important context that, for example, if you go to direct retrieval and you give model a piece of code, you kind of miss all that surrounding context. So anyways, the agentic models came into their prime light, and the name of the game started to be who builds the best agentic harness. And you can also call it the era of SWE-bench. Some of their listeners might be familiar. It was one of the most popular benchmark, SW for software engineering, and then bench for benchmark, obviously, right? So the benchmark had, I think the original one had about 2,000 samples sourced from open source Python repositories where there were real PRs, and then they kind of backtraced them to their issues that like a bug fixes or feature request that initiated those PRs, and then they could also find some unit tests so the solution could be validated. So that was the benchmark that essentially tried to emulate part of real software engineering process where people have to implement new features or fix bugs, albeit obviously in kind of constrained environment, one programming language, open source domain and whatnot. So, and anyways, that benchmark, when prior to Sonnet 3.5, I think their basic model scored like low single digit percentages, about 3 or 4% at best. And then after Sonnet came out, both the harnesses started to improve and the model started to improve, where again, today it's probably the best models and harness could score about 80% on that benchmark. So think about, well, like from that perspective, it's an amazing result, right? Where these are true real life engineering problems, and code and agents can solve 80% of it. Now, that's not necessarily translating into the 80% productivity improvement for real engineer working in complex environments, and we'll talk about what and why. But that's the second, I would say, second generation. That's when the term vibe coding come to the arena, when people started to realize that, hey, those agents can actually do some very, very interesting things. And then I think right now we're moving into the third generation. It's not yet obvious because we're kind of at that cusp. But basically, when people use those agents and models, they can use them what I would call randomly, just vibe code, if you will, or you just randomly throw something at LLM and hope that it solves the problem. And then there are people who start using it more systematically. which is what most people today are familiar with and what they associate with AI agentic coding, is you have a pretty good model, you have a pretty good harness that gives the model access to tools like ripgrep, where it can search through your repo, and gives the model access to shell, where it can execute other commands. And kind of off you go. If you're working on something simple from scratch, it can carry you pretty far these days. If you're working on more complex existing repository, typically this harness and model will need a lot of guidance from you. And where this guidance has evolved is that people started coming up with new workflows, or as I like to call them, systems that help them get significantly more from the models. And we can talk about theoretical kind of foundations of what and why, but that's what's in the industry starting to get called AI first engineering. So in that approach, you have to change the way you sequence your work and the way you use agents to get the most out of them. And when you do, it opens up a new horizon. We have examples both in our company and in our customers where the agents can work semi-independently for hours, where they can implement significant units of work. It could be major refactoring on your code base, or it could be implementation of a new feature. And those patterns, they shift their way you use agents, and a different kind of higher level tooling, if you will, where it's not only about agentic harness that can execute simple AI command for you. You now are trying to sequence multiple agents. You're now trying to run them in parallel. You now try to execute sub agents to take care of that more sophisticated workflow. And that requires, again, new way of organizing your software development lifecycle, and that requires better tooling and better models.
And as you mentioned, vibe coding is a term that largely came about, I want to say, early in the summer of this year, 2025, is when it really came across my radar in a fairly consistent manner. And to your point, we have, I think, exhausted that trend a little bit. Although it depends on, I guess, which spheres you're operating in, where some people have already moved past it, to your point, to this more AI native engineering workflow. Some people are just now coming to awareness of this idea of vibe coding. And vibe coding, from my understanding of how people are defining it, is largely throw a problem at the model, don't even look at the code. As long as it does what you told it to do, then great, you're done. And to your point, that is something that you can do in a very limited scope or in a greenfield project, but it's not something that you want to trust in a production system that you have been developing over the course of years and requires the interaction with a large number of teammates. And that also points to another interesting aspect of where we are currently, which is the broader conversation of how much responsibility should the model have versus the human who is piloting it, and what are the axes of control and the interfaces for managing this symbiotic relationship that we're having between the models and the humans in this process of software engineering. And I'm just wondering if you can talk to some of the ways that you're thinking about that aspect of balancing acceleration and productivity enhancement with control and visibility, particularly because of the fact that these models can generate orders of magnitude more software per unit of time than a human typically can. And also the fact that volume of software or number of lines of code is not the metric that we actually care about as software engineers. We care about, does it do what I want it to do? And if it can do it with less code, then all the better.
In terms of kind of control and producing high quality code. So first, we're not starting from zero as an industry, right? We've been collectively, humanity, working on developing software best practices, software development best practices, pun not intended, for several decades right now. And this has been rapidly evolving area. When I started my software engineering career, a lot of the processes were basic cowboy coding, and there was waterfall in some organizations, and there were like this iterative processes, and agile just starting to appear on the horizon around the turn of the century. And so we, as a collective, we're developing processes that help us ensure quality and more predictability in software development processes for a while. because humans are also uneven. Our productivity varies ups and downs even individually, and then across human pool of engineers, it varies more broadly, right? So we have certain gates. Most engineering organizations have code reviews for PRs, right? Good engineering organizations have auto tests built in their CI process. So there are guardrails that are already over the last decade built in the engineering process. And so with AI, it's quite natural to expect us to at first at least adopt similar guardrails, right? And then potentially extend them further. We as engineers should think not just at the level of engineering their end solution, but also at engineering the process. And so this is where kind of again that whole discipline of AI first engineering comes in place. For example, in our company's AI first engineering process, it's prescribed to use test driven development, right? So when before LLM is given a task to code, it is given an instruction to write tests so that it would compare the results to the test. In fact, maybe it's helpful if I take a little detour and briefly walk through our own company's internal AI first engineering process. Your company might be different. Again, it's very rapidly developing area, but it looks like it is converging to same set of practices. So in our company, we start with an idea. Think of it. A good example would be user story in Jira, right? So then that user story gets translated into a spec, essentially, right, or PRD, we should say, where it's a more detailed requirements document, and it's done with AI but supervised by a human. So every step of the process that I'm going to talk about, there's human gate, and even gate is the wrong word. I should say it's a collaboration of human and AI, where AI is tasked to do something, but human is in the driving seat. So first, their PRD is developed. Then from that PRD, a tech spec is developed. This is where, again, as a result of collaborative work, where most of their characters are produced by AI, but there's still significant amount of thinking that's done by human. That tech spec contains important interfaces that need to be created or refactored or whatnot. Contains typically things like control flow diagrams. If it touches the data model, it will be updates to the data model. So basically, it's a succinct and correct description of what needs to be done technically. And from there, the detailed step-by-step plan is generated for the agents to execute, and then the agents they're led to execute on the plan. Now, first of all, as I said, every step is human gated at this point. Not only that, but at our team, we ask that it's an act of active collaboration between human and AI. Oftentimes, the verification is done not just by humans, but by AI as well. So for example, if technical spec is produced, it's super easy to then shoot off an agent in the background that will look through that spec and cross-check it with existing repo to make sure that it's dry, if you will, right? There is no code that's being duplicated, and that it's also not hallucinating and it's compliant. So we kind of layer both human checks and AI checks in that process. Again, if you go level back up from the technical spec to PRD, it's common for us to kind of shoot a note for an agent to generate PRD, but then shoot a note to another agent to just review it and kind of provide any quick feedback. So again, as we're becoming more proficient in using agents, our agentic sort of collaboration becomes more and more sophisticated when we engage more and more agents more and more frequently. And then to the point where I started with control and verification, there was a well-known essay, I think by Sutton, that verification is the ceiling of AI capabilities. And even before I stumbled on it, sorry, this was my personal belief. Like their intelligence of the system, where we define intelligence as ability to achieve real life goal, is to a large degree defined by ability of that system to verify the results of its work, either in real life, which is the best, right? Or sometimes at least with a strong world model that gives good enough approximation of that verification, if you will. So at our company, we prescribe our AI and our engineering organization to use test-driven development when we're in AI first workflow. So the tests are implemented before the code, and then the code is tested against those test cases, and that's a big part of verification. Now, on top of that, something that we're actively working right now, and this is not necessarily part of the last step is not necessarily part of common AI first system, but it's part of our AI first system, is we're now tuning an agent that will take their PRD and create acceptance tests in their BDD format, to be behavioral driven testing. So that gives us kind of a higher level verification compared to the more typical, typically if you say TDD, people think it's unit testing, which, as you know, doesn't always test the complete system and doesn't always test their kind of correct behavior. So as companies are working on transitioning into AI first culture, it is indeed extremely important for them to think about those gates and quality checks. And if you want a scalable process, then it's quite natural to think about how you can automate that, right? If you're going to generate 10 times more code with AI, you need to test 10 times more code. And unless you want to blow up your QA organization to be 10 times of your engineering organization, you will have to use AI as heavily in that verification process as you do in your coding process. And it's an effort, right? Most organizations do not have good enough test coverage in auto tests. They do not have enough end-to-end testing capabilities built in. And so again, as part of that transition into AI first culture, you absolutely need to think about building the right guardrails and verification. I'll pause for a second. Again, you brought up so many different interesting questions. We could talk about vibe coding. We can talk about context management and where models are good at and not good at, and where humans are good at. So there's a host.
Absolutely. I'm sure that if we had unlimited time, we could probably go on about this topic all day. But for purposes of this, for now, I think that maybe the next interesting place to go to before we get into some of the aspects of single player versus multiplayer and managing the team level context, I think just digging more into some of that context engineering and context management aspect that you touched on previously about the code rag and the re-ranking and how the models are now to a point where some of that is obviated. And then you also have, most familiar with the Aider project, which will generate a repo map of some kind of high level snippets of, so these are some of the function signatures that it feeds into the context for the model, and just how you think about the overall engineering effort of being able to collect and provide appropriate context to the models, particularly given the varying ability of the models and how that factors into the approach that you're going to take when you can understand, okay, this model is great at this, but not so great at this, or this model, I need to fall back to doing the code rag and re-ranking algorithm, and just some of the ways that the specifics of the models and the repository factor into how you think about that context management and providing appropriate information.
In terms of kind of optimizing for the model, my one of my bitter lessons, and again that's a reference to an essay with the same name, learned in the space, is that I would not recommend optimizing for the weak models, because the models continuously get better. So whatever is the best model today that you can find and work with it. Don't try to optimize for the weak model, because even the weak one is going to get better tomorrow, right? So that, in my opinion, is easy waste of time. So pick the best model and work with it. Now, in terms of context engineering, it serves two distinct and important goals. And as a byproduct, it sort of unlocks an incredible third thing that people don't talk about. We'll talk about it in a second. So the more obvious goals is, one, you need to give model their right information to work with, right? So as we all know, for LLMs, it's 50 first dates. It knows nothing about your repo unless you give it the context. So one way or another, it needs to receive that context. And you could say, well, the model is agentic, let it rip it. They'll find the context by just messing around, kind of like Roomba, that doesn't have the map of your floor and just bounces around the corners in order to vacuum the whole surface. Well, that's not efficient, and that inefficiency manifests in two ways that most of you are familiar with. So first of all, context window for LLMs is limited, right? So typically 200K. Right now, it could be million tokens, sometimes 2 million, but again, most typical for strong models, it's around 200,000 tokens. So if the model bounces around a lot, it's going to fill in that context with the bouncing around, and it's not going to have enough working memory, if you will, to solve the actual problem. So that's issue number one, right? How could we give model the right information? The second issue is that despite all their claims and needle in the stack benchmarks and whatever, models are not great at multi-hop reasoning over very, very long trajectories, right? So what it means in simple language is that if you can give the information to the model concisely, then you will significantly improve the performance as opposed to if you mix it up in a bunch of noise. And that noise can be confusing. So the way attention works, and you can test it in real life, is that if you add some information into their trajectory, it will bias the model towards that information, even if that information, whether that information is correct or incorrect. I'll give you a very funny practical example. So up until recently, if you ask a model, doesn't matter, it could be Claude, it could be GPT, you ask it to write code that uses the model that's recent, that goes beyond the training date cutoff, the model will keep ignoring your instruction and go back to the previous generation. You ask GPT 4.1 to code for GPT 5, it will fall back to GPT 4.0 or whatever. But you can solve for that. And the solution is beautiful. You go into your prompt and you type GPT-5.GPT-5.GPT-5, you type it like 5 times, and the model, quote unquote, gets it. And it's not because you, again, quote unquote, yell at it, nothing to do with that. It's just because it's sort of that those tokens in the context window bias the model towards kind of overcome their inherent bias from the training data. And that's true about humans. We all have anchoring and things that we can talk about how our own brains work. But anyways, the context, the more concise you can pass the information to the model, the more successful it will be in getting to the right solution. That's one part of context engineering. How can we find the right information, condense it, give it to the model, so the model has more working memory. Now, the other interesting part of context engineering is that, in my opinion, it's essentially a higher level unlock on inference compute. So if you think about the previous big breakthrough in LLMs, it was the reasoning model, which basically took their chain of thought prompting technique and put it in a RL training harness and kind of allowed the models to, again, unlock that inference time compute by producing longer chains of thought. Essentially, this is what, at the meta level, AI first engineering is doing. Instead of just throwing model to single shot a solution to complex problem for you, you're breaking it down in steps, and every single step you're running an agent, at least one agent. And again, typically in our scenario, it's multiple agents. So it's the original agent, it's the review agent, it's the correction agent. So every single one of those agents has a concise input and has more working memory. Plus, you're adding all of that compute together, so the final solution leverages that inference time compute for many agents and essentially leverages your human inference time compute as well, because you're part of you're the director of that process and you're the reviewer. So that brings, again, that inference compute number to the whole next level. And that's what, in my opinion, makes context engineering so much more powerful. And interestingly, just like with chain of thought prompting technique, the models codified it. Anthropic is right now, to some degree, codifying some of these practices. If you use Sonnet 4.5, when you ask it to work, it basically does what a good AI first engineer would do, try to generate spec and then PPRD and spec and whatnot. Now, the only thing it misses, though, well, not only, it misses two things. It misses your inference time compute, because you're not reviewing those specs, and your injection, even if it's just like 3 words, it could be very powerful in that process. And then again, it doesn't automatically reset the context for you, which is to some degree handicaps the model compared to what AI first engineers do today. So that's a little bit of context management and some meta thinking on it.
The other interesting aspect of managing the scope and context of the information that you're providing is, broadly speaking, most of these agentic engineering tools are by default scoped to a single software repository. And in order to be able to understand more fully the role of that software repository in the broader operations context when you actually get it deployed, you often also need access to maybe a different repository that has the deployment information, or maybe it's a part of a service-oriented architecture, so you need to understand what are the other services that this is communicating with. And then that also brings in the question of being able to introspect aspects of the dependencies of the project. And I'm wondering if you can talk to some of the strategies for being able to span across that broader set of context that you may or may not need to bring in for a given task.
You absolutely have to solve for it. I'll give you several different ways, so you have the full toolbox and you can decide. So for first, and this is not a sales plug, but our product does support multi-repo indexing for this specific reason, right? We as a company use microservices. My previous companies use them. A lot of companies do. Oftentimes when you use microservices, you use multiple repos. So it's very, very natural for any modern team to have kind of their repo sprawl. And from that perspective, giving ability for agents to glance into their related repos is very important. So that's tool number one. Tool number two is, which I don't like, and we did prior to multi-repo indexing, this was one of the approaches we used in our company, but again, I hated it personally. So, which is you kind of create a higher level script that pulls out the repos into the same parent folder, so you kind of have a structure on your laptop that's not reflected in your Git, essentially, right? That contains multiple repositories, and that allows the agent to go across them. And you can run agent at the higher level, if you will, the kind of above your repo on your local machine. So I don't like it, but that's one workable approach in certain cases. Another one, which is the third tool, is both a shortcut for simple structures, but also potential necessity in very, very complex structures, is you might want to spend some time into creating MD file that will describe, that will kind of curate the information that you want to give agent about your different repositories. And you can do that, by the way, with the two other approaches that I described there. This is not contradictory tactic, right? It's not exclusive tactic. You can combine it, but sometimes you might have your own quirks. For example, maybe you have a repo that's deprecated, but there's nothing in that repo that says it is deprecated. Again, that's an omission, and the best solution is to actually deprecate that repo. We all know the right solution, but we also know that in real life, there are a lot of things that are done not in the right way. And so from that perspective, having good instructions helps, I found, both human and AI. And so again, good way to think through that is, what would you give to Joe when he joins your team and you don't want him to mess up and you want him to get on board with your solution in the next 30 minutes as opposed to the next 30 days. So, and then the fourth one, which we in our own organization applied, is we actually simplified some of that chaos in order for both AI and us humans to have better time at working with our solution. So I think, yes, you do want to use AI first engineering across all levels of complexity, but their nature of the models and the nature of human knowledge and skills makes it most usable in a certain progression where, say 6 months ago, AI first engineering was most appropriate for simple greenfield project. And right now, AI first engineering is fully applicable at the scale of a company like ZenCoder, where we got about 50 engineers, at a scale of product like Claude Code. Again, both us, ZenCoder and Claude Code, our engineering teams are AI first, but at the same time, maybe not yet ready for overnight transition at SAP. So you got to be thoughtful about carving out their space in your product roadmap and the space in your repository sprawl where you could truly go AI first as opposed to AI assisted, right? And kind of use that island, more controlled environment where you can battle test it in your own organization and kind of from there scale to more complex engagements, right? And more complex setups. So I would recommend that more progressive approach. And obviously, again, the easiest one of that progression is greenfield. Sometimes again, a lot of companies have new initiatives, right, that they want to bring to market quickly. And that's probably especially if you think that initiative can become the seed of the future platform that can overtake the legacy system. That's perfect for AI first, where you can from day one build something that moves at their 10x speed of your today it's probably not 10x, today it's probably 2x 3x, but moves at the speed 3x the speed of your previous software development lifecycle, and is fully covered in tests, and is done the right way from the repo structure, architecture structure, and use that to kind of, instead of trying to rebuild the whole legacy, which is its own project for the next 2-3 years, kind of focus on their new greenfield development and try to make that in the market and in your tech stack overtake the legacy system. That's one thing that, again, we've done internally. We had that repo sprawl and microservices sprawl, and one of the solutions for us was that as their market changed and we needed to come up with the next generation of our product, we basically took the best from the previous one, but essentially started a lot from scratch. And that next generation very quickly overtook the previous generation of our product.
That's an interesting observation as well, because microservices as an architectural pattern is largely solving the challenges of communication patterns between engineers more than it's solving an issue around deployment or actual operability of the system. And as you bring LLMs in as a communication partner, that also changes the communication patterns that you're going to have, which brings in a different factor to Conway's law that defines how you think about structuring your software. And so I'm wondering if you have any insights in that regard from the lessons that you've gained from building ZenCoder and working with customers and observing the ways that people are engaging with LLMs for actually managing their software and how it's mutating the ways that we think about system and software architecture.
I think people need to be more brave right now, where LLMs give you ability to understand the code and scopes that you did not own before. You might have boxed yourself into like, I'm a front-end engineer, right? I don't understand how that back-end stuff works. So vice versa, you're like I'm a back-end guy, like I don't know much about the TypeScript and this and that. And that kind of siloing significantly slows down decision making process, because a lot of technical decisions, they sprawl different scopes, and again, people kind of over the last decade got comfortable with a certain zone, and so a lot of those decisions, they become committee decision, where you're offering kind of a half-baked solution that only covers your part and hope that somebody else will cover the other part. And versus right now, I think you have agents like ZenCoder that can help you understand internals. You have agents from OpenAI and Claude that can help you research open source comparables, kind of wisdom of the crowd, whatnot. So you can very quickly build full contextual understanding of the whole picture. And instead of hoping for a committee decision, you can come and say, hey, here's what I think their solution should be across all the scopes. And then people who own those scopes can quickly say yay or nay or correct you, right? Like, it's not about being right the first time, but it's about accelerating the speed of making the decision. To your point, kind of changing that communication paradigm and changing that to more complete ownership of the system. And finally, I already mentioned agile in the conversation today, kind of that transition around 2000. There are a lot of parallels. I remember before Scrum, which is their kind of staple of modern engineering practices, there was this quirky process called extreme programming that got very popular for a brief second, and then everybody forgot about it. But part of their values there was being brave, and another value was kind of the shared code ownership. Instead of siloing, you kind of all had a better exposure to overall code, and there was active practice of rotating you across all the parts of the solution, so you would have that full picture. So today kind of reminds me about the same principles, and in fact, they might be even more valuable today, because as the models become better and better, where we humans shine is that aggregation of context across the whole solution and across various disciplines, and merging it with our intuition about the product and the market and the mistakes that we made in this company and the mistakes that we made in the companies before. So I think people should embrace that and do that quickly. And that's kind of your value, how you become extremely valuable in this AI first world, as opposed to you trying to compete with LLMs, which makes no sense. I don't think that's the right path.
And extending that question of communication patterns and Conway's law, a large number of the agentic coding tools that have been developed are still very much focused on the use by a single engineer. And I'm wondering if you can talk to some of the ways that you and other vendors are thinking about the more team based and multiplayer aspect of software as an exercise, and how these agentic systems can both capture and distill some of the best practices of the most productive members of the team, as well as provide useful guardrails and starting points, and also just broadly visibility to everybody on the team as far as what the agents are doing, how they're operating, and how everybody can most benefit from them.
You're spot on, and it's a glaring hole in the industry, but it's also a very explainable hole, right? Because when you can improve the productivity, individual productivity by 2x or 5x, like you first have to do that. And then on the journey, if you're trying to improve that, but the quality isn't there, then your first goal is to improve the quality and accuracy of that solution, right? Before you start thinking about collaboration. But then once the individual angle will tap out, or once again the accuracy of the systems, we put it another way, like once the accuracy of the systems gets better, the collaboration aspect will become increasingly more important. And by the way, a little tangent there. I think the key unlock for the whole industry is going to be self-verification, because right now the models are already getting good at code review, but they still produce a lot of false positives, and false positives can completely blow up the trajectory. Like if you ask the model to review and another model to act on that review, yes, it'll fix some issues, but it can also like completely take it away and create like some monster, right? And so, but we're on the cusp of that self-verification, and once we're there, the accuracy will skyrocket, because then the models can iterate and you can parallelize and blast multiple agents and whatnot. So, and then once that happens, their kind of collaborative aspect of developing systems will become significantly more important. I'll give you a very simple example. In that spec-driven process, what should happen as the next evolution of the category is that execution part should be fully given to the agent. Like now, organizations still hold dearly to code review. Why do you need code review? If you have reviewed the technical spec, and again, I'm not saying jump like 10 years in the future. I'm just saying the next logical jump. Say you reviewed the PRD and agreed on it. You reviewed the technical spec. You agreed that this is the right implementation. You, as an organization, agreed on your verification framework. Well, like you've got good automated test suite, and then the guidelines for every implementation include test-driven development and end-to-end testing and whatnot. What difference does it make, like, if you use quicksort or bubble sort? I'm making this stuff up, right? But like, there's zero difference. Like if we agreed on the high-level parameters and the guidelines, then it should not matter. So, but that quite logically puts their review component up the chain. So now we need to be reviewing those specs, and as you know, those specs are created in active collaboration with AI. So it's quite natural that then that spec creation process, instead of me iterating with my AI agent, becomes more like me iterating with my AI agent and with you, kind of three of us, right? It's not like sequential, but more collaborative process. And this is where I think, again, that next collaboration layer comes in. And today, the existing players are not ready for that. So Google Docs, for example, a wonderful product, use it every day. They're OT is not built for that sort of block interaction with AI. Notion, wonderful product, use every day. Not the underlying data structure is not built for that. Otherwise, they would already have it in the product. They've been mocking around with AI for the last 2 years. They still don't have it. So that's the non-existing layer of technology. I spent more than a decade of my life building Right, which was again collaboration at its best. I was a seed investor, early advisor in Miro, which was another category-defining collaboration company. So I did spend a minute thinking about how to make teamwork more efficient, and I think that's a big thing coming to AI next year, along with again that self verification, which will allow us to run more agents in parallel, run more agents in background, and again elevate the level that we humans operate as we're trying to engineer complex systems and bring them to life in a reliable, secure way.
The other aspect of agentic coding is, at least in its current state, it doesn't necessarily make sense for every software operation to be done by an agent because of, in particular, issues around cost, but also issues around precision. And so I'm wondering if you can talk to some of the heuristics that you use to determine whether and how to employ these agentic systems versus just doing it manually using your trusty old text editor.
Good question. I think AI first is best at a good unit of work. Actually, let me start from maybe the very bottom. Super quick change that you're already there, right? You know what to change. Just do it by hand, right? You don't necessarily need to ask an agent. Then, quick bug fix, the file's not open, whatever, just single shot it at an agent, it should be able to do it as well. Then you're trying to implement user story that changes their product technical aspect a little bit. It's more than rounding the square button. It's you're introducing new data structures into the product or new page or changing some interface in a variety of different ways. I would say use AI first approach. Go through those steps. You kind of implement a new module for your product. You're refactoring existing sizable modules. So go AI first. If your infra, quote unquote, is ready for that. By infra, I don't mean GCP. I mean your DevOps, your AI ops infra. Like you've got the right repository and you understand how all those things works and whatnot. And then something even higher level, right? You're trying to design high level architecture for a new solution. Say for a company like ZenCoder, let's say we roll back the clock several months ago, we're implementing autonomous agents, right? In for your CI/CD. How do we architecture that? So that's human driven process that's heavily AI assisted, right? You would run a lot of research agents in the background, but you're still in the driver's seat. You're not like asking AI to instantly generate code for you. You're trying to generate an architectural document that will go through the team review and whatnot. But as you do that's heavily AI assisted. So I'd say there's a sweet spot where that unit of work is AI first, and then the levels above and below are AI assisted, and then the one level above and below is just human, because either it's too complex for AI or too simple to even bother doing it with AI.
And then one of the other major aspects of considering when and how to invest in one of these agentic engineering systems is in terms of cost, particularly given the high degree of variability, where in many cases it's still going to be cheaper than hiring another engineer, but at least with an engineer, you're hiring them on salary, you know what the cost is going to be, so it's predictable. And even if the cost is an order of magnitude less than a full-time engineer, it's still unpredictable. And so that provides a lot of fear and uncertainty as to how and when and in what situations to use these agentic systems. And I'm curious if you can talk to some of the strategies from the engineering and vendor standpoint, but also from the consumer standpoint about how to mitigate some of that risk and uncertainty around the potential for cost explosion.
Mm-hmm. Yeah, I'll start with saving and go into a paradoxical thesis on saving. So I'm a big believer in subscriptions, right? So I think they work good for businesses and they work best for vendors and they work best for buyers. That's why at ZenCoder we're a subscription-based product, not API-based product. And then from the subscription perspective, that's why we also opened up the doors for users to bring their existing ones. So there's about 20 million ChatGPT subscribers today, and right now a lot of people don't know about it, but if you are paying for your ChatGPT subscription, you can also use OpenAI tools called Codex CLI, a command line tool, and they're fairly generous with how many tokens they let you use on that Codex CLI, and then you can bring that Codex CLI into ZenCoder. So you will have the best of both worlds, right? You would have ZenCoder UI, and you underneath it, you will be leveraging your ChatGPT subscription that you're already paying for. And for us, that starting tier is like we're actually free to start in that. If you want more features like multi-repo, whatever, we'll charge you for that. But if you just want to bring your Codex CLI tool and use our UI in your VS Code or JetBrains, you can do it for free with us. So essentially, it costs you nothing and you have full control. Then Claude from Anthropic was very generous up until recently with their subscriptions. Now they start to tighten that down very rapidly. But up until recently, again, they were very generous. For example, one of our own engineers, and we at ZenCoder allow you to bring your Claude Code CLI tool, which essentially allows you to leverage your Claude subscription. So one of our engineers burned through about 3.5 billion tokens in August, which in API pricing, including cash and discounts, was about $11,000 worth of API calls in 1 month. And we paid about $200 for his max subscription back then. Vendors start to tighten those subscription kind of limits, but still, if you have ZenCoder subscription, you have ChatGPT subscription, you have Claude Max subscription, between the three, I'd say you can do a lot. And that's all in is going to cost you, depending on, again, your needs, between $50 and $500 a month. Compared to what's your fully loaded cost of engineer, it's a tremendous amount of savings. And then in general, for my own team, I always encourage them to use the best tools and the best models. For example, prior to Sonnet 4.5 between Sonnet 4 and Opus 4. I always encouraged my engineers to use Opus 4. I know it's more expensive, and I know, again, the bill can go high pretty quick, but it's still significantly cheaper than alternative cost of time to market, or even my direct cost of engineering labor. Again, I try to apply personal standards to the team. I've been subscriber to Chat GPT Pro since the day it launched, and it's been extremely helpful for me in doing research and so all sorts of different topics. I've been subscriber to Claude Max since they launched that offering. I use ZenCoder every day, and so I feel right now I'm significantly more capable at my job than I was a year ago when I did not have those tools and those LLMs at my disposal. Like I can measure the difference and measure the impact that it's making on myself and my organization. So long story short, subscription is the way to save. Bring your own subscriptions or use ours, whatever it takes, and then use the best models. It's still cheaper than making bugs or making wrong architectural decisions. Like at this point, I see zero reason why you shouldn't use AI to cross-check your architectural decisions. Just like you're trying to review AI code, well, let AI also review your decisions and your code. Well, like it's free, and it can significantly improve the quality of whatever you're doing.
And in your experience of working in this space and building a product in this space, what are some of the most interesting or innovative or unexpected ways that you've seen coding agents applied?
We're trying to come up with the term, we sometimes use business vibing. There's this whole generation of entrepreneurs who use tools like ZenCoder to essentially manage their business. They would connect a bunch of MCPs, they would put their sales call transcriptions in some text files and folders, and they would run all sorts of sales, marketing, and business automations through coding agents. So that's unexpected, and I think we can do better by them. I think we can give them better product and better interface that's less techy, if you will. Those are your kind of early adopters, innovators, and pioneers that use tools in unconventional ways, and they kind of pave the way for their later people who will use kind of simpler solutions to achieve the same productivity results.
And one of the other interesting aspects, too, that I forgot to bring up earlier is there are many styles of agents, and there are coding agents that operate autonomously in some hosted environment, unmoored from a developer's laptop, versus agentic editors that bring the agent loop into the process of doing the work, whether that is something like a Cursor or a Windsurf, or even these Claude Code and GitHub CLI and Gemini CLI. And I'm wondering if you can talk to some of the juxtaposition of those styles of agent-based engineering as well.
I think we had this debates back and forth internally, both kind of for our own use and for the product. I think ultimately you need to have both modalities. So there should be code first modality, and most engineers think that that's the main one and that's going to stay there forever. I think they're overestimating the importance of that modality and the longevity. And then there's got to be agent first, because as you're starting to manage this fleets of agent and their more complicated workflows, both sequential ones and then parallelizing multiple agents. Again, the whole industry is not yet unlocked. Very simple technique, which is ensembling, right? In machine learning, we always use ensembling. So you should be, for a complex problem, you should be running multiple agents and comparing the results and merging them together. So all of those things need proper UX and UI in order to unlock mass market use. And that means AI first product rather than kind of code first product. So, and they should just live happily together. I think the good example for that is GitHub and VS Code. VS Code has support for GitHub, and you can do the operations from there, but it also has its dedicated web interface, right? And it has a distant CLI interface. So and depending on your use case, you might prefer one or the other. So I think that's where it's all heading. And again, I think engineers overestimate their own reliance on ID just because they haven't yet seen very capable AI agents that are more autonomous. Once they do, again, they will start appreciating other surfaces more. Again, not as a replacement, but as an addition. You're not trying to bring Slack into your VS Code, right? Like you prefer a dedicated interface to it. VS Code is already pretty busy. So if you're trying to manage complicated AI workflows and fleets of agents, I don't see a reason to bring all of that into VS Code interface, which already serves its purpose, right? It's kind of already dense. I think both are awesome and will work well together.
And in your experience of building a product in this space, what are some of the most interesting or unexpected or challenging lessons that you've learned while building ZenCoder?
I knew that the pace would be insane, but I still underestimated how insane it is and how quickly you need to be able to pivot to their next generation, if you will. I'll give you an example. We built state-of-the-art rag, right, an incredible re-ranker. And while we were still kind of fixing the issues with that re-ranker, if you will, because it's one thing to build it in the lab and another thing to build it in production, we lost a little bit of time in implementing good UX around Sonnet 3.5, and our competitors kind of swept that opportunity, right? And we did very quickly came back on top, and we stopped sweep bench, verified at some point, and we doubled the sweep bench multimodal, and we did 20% more on swill answer. All of that great things, but time is everything, and if we done it a month earlier, it'll be a very different trajectory for our brand. And again, that month is not because we were stupid. We knew that was coming. We just were too slow to drop everything that we were doing and start sort of like running towards the new target. I learned that lesson, so we're moving much faster right now. And again, we retooled the whole company around velocity. So retooled our architecture around velocity, our processes, our team, and we're AI first right now. So right now I'm ready for for anything, if you will, right? And we are moving super fast to lead that next generation of what's coming around the pike. So that's one big lesson. And another lesson is interesting, and it's more on the business side. So if you're familiar with kind of business books, they all teach you to focus on your core customer and start with one segment and then go to. And when I started my first company, Reich, I fully understand their theory behind it. I appreciate it. I fully agreed with it. And I still did the exact opposite. Like I felt that while building Reich, I was building the product that is needed by everybody. Like in business, you're always managing work and you're always collaborating. So it doesn't matter which department you come from, right? So I built the generic product, and it was hard, but it was worth it. And it was brilliant, and we helped millions of users. And at ZenCoder, it's kind of funny where instead of learning that lesson to ignore the wisdom, I went with the wisdom where, like I said, hey, when we started, models were pretty weak, and so we needed to do a lot of work on kind of making them better. So there was no way model can be like autonomous for you. Vibe coding didn't exist, and we're like, we're going to help professional engineers get the most out of those models. We know they're not perfect. This is what we're there for. We build incredible context. We'll correct all of their mistakes. We'll babysit them. We'll do whatever it takes for the professional engineers to get good value out of that. So that was our starting segment. And then as vibe coding got onto the radar, we're like, well, it's kind of cool and nice, right? And eventually we'll get to it. But our main customers are professional engineers, so let's stick with it. And that was a big mistake, because professional engineers, while still being the core of our business, they don't go on YouTube and rave how cool your product is and tweet with it and whatever, right? As opposed to for vibe coders, people who have not coded before, like they're like, it's mind blown. They type something into their ID and suddenly they have the website that they dreamed about, or the app that they thought about. And so I think that emotional aspect of it is so powerful and so valuable for the brand that, and we kind of stick to our core audience, like, hey, multi-repo indexing and full support for JetBrains in addition to VS Code and this and that. And so we kind of missed on that opportunity. And again, I blame myself, because I kind of took logic over the heart. And my mission was always helping people unlock their creativity. And from that perspective, like, vibe coding is a natural area for that, right? Like, you're helping people create it at its purest form. So that's the lesson, one other lesson learned. So one is the importance of speed, and the other one is importance of kind of trusting your heart sometimes over your logical mathematical brain.
What are the situations where you would advise against either ZenCoder specifically or agentic coding in the large?
There's one very distinct one. If you're LLM and not human, you should probably not use ZenCoder. But if you're human with your own brains that can, and you're in the driving seat, then it's an awesome tool. Just like, you will, by using that, you will build an understanding of whether that tool is appropriate or not. It's a little bit more complex than hammer versus a screwdriver. With hammer and screwdriver, it's a little bit easier. Like, here's the nail, here's the screw, don't screw it up, pun intended. So as opposed to with ZenCoder, as you use those products, I think it's helpful for you to start using them in different scenarios so you get first-hand feeling of where it works well and where it doesn't. I also think it's important for you to put some effort into building your own setup around those tools, because for us, it took an effort to change into AI first engineering. And a lot of engineers don't want to take that effort, right? So they need support, and they need some push top down, and they need some help, and they need the prompts, and they need the tools, and they need examples of the champions. Likely in most companies, there are kind of more early adopters types there. And what I would probably recommend is for people who lack the motivation to try it on your weekend for some vibe coding stuff. Because if you only tried it in your prod, right, again, there needs to be an effort that you put in before you get the most value out of it, as opposed to if you try it in greenfield, you might get your own like, oh my god moment. And so I would recommend everybody who hasn't done it yet to vibe code on the weekend. And then I also would recommend everybody to challenge your own assumptions with their every next major model bump, right? So GPT-5 is significantly more powerful than previous models in for O and for 1 and whatnot. Even the latest Sonnet 4.5 is significantly more powerful than Sonnet 4. Like internally, my previous guidance was for my team to use Opus 4.1 instead of Sonnet 4, versus right now my internal guidance is to use Sonnet 4.5. So I don't have good words when I talk to somebody and like, oh, this doesn't work. I'm like, what did you use? Well, I use like Cursor with GPT-4. And and also, by the way, they also don't know that Cursor cut their context very, very aggressively. So they haven't even seen the full power of that model. And by the way, we're like 2 generations ahead on the model and like 1 generation ahead on the harness. So, and then they're like, oh, it doesn't work. So again, you got to be trying this stuff, because this world moves very, very, very quickly.
And as you continue to build and iterate on ZenCoder and help to push this frontier of agentic software engineering, what are some of the things you have planned for the near to medium term, or any predictions that you have for the maybe next 1 to 2 years? Because projecting further beyond that is a fool's game.
Yeah, so my projection is that next year is going to be as dramatic as this year. So that we will all be on the next generation. And specifically, I won't repeat the whole detail, but we talked about those things. So I do think that self-verification will become more feasible. I do think that this will be immense unlock for compute at a variety of different levels, parallelizing, which is going to improve the accuracy of ensembling, I should say, right? Which will improve their accuracy, parallelizing, which independent tracks, which will improve the productivity, because you're going to be able to do more things. And as those things happen, you'll also be able to run more of that stuff in the background and in UCI and whatnot. So a lot of the claims that we heard a year ago will finally actually become the reality next year, if you will. Or like some of the outlandish stuff, or like, oh, just point this stuff autonomously at complicated Jira ticket and we'll produce the PR for you. Kind of that sort of BS that we heard a year ago was BS a year ago and will be real life next year. So there's that. And then the other thing that we discussed as this happens on their individual productivity side, their kind of their teamwork with AI will become more real and more tangible. And that will keep us all busy building and learning through the next, I'd say, 12 months.
Are there any other aspects of the work that you're doing on ZenCoder, or just this broad space of agentic software engineering, that we didn't discuss yet that you would like to cover before we close out the show?
No, embrace the exponentials and enjoy the ride. And I believe there is a tremendous potential for humans. It's not the first time we bring up the next level of abstraction. I've seen punch cards physically. I've never programmed them, but I've seen them. I have written a little bit of assembly code. I have written C code and C++ and Java and Python. And people underestimate what we have today, like with so many open source libraries and cloud and whatnot. Like we're already operating so many levels of abstractions above what we had to do a decade ago and then 2 decades before that. And so this is just the next level of abstraction. It is a little bit different. And for some people, it does mean reskilling, right? But again, there are not that many COBOL developers today, right? So it also did need some reskilling. So that's common. Just be open and enjoy that progression.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling, technology, or human training that's available for AI systems today.
The biggest gap is there's huge number of organizations that can already embrace AI first engineering, at least at some new initiatives. And that will open their mind to kind of, and open up their productivity so much, and they can bring it to the rest of the organization. So it is coming. There are more and more people embracing and adopting those best practices, but there's still huge opportunity. And then the other note is I would recommend people to use it as a system. That's a very common mistake that I've seen as companies a decade ago try to implement agile. They would pick like 1 or 2 things and they would call themselves agile. And they would essentially be doing things the old way. They would pretend that they transformed the organization. And then they would say, well, this stuff doesn't work. Well, you have done zero transformation. You just kind of slapped some lipstick on what was already there. So it is a different process. It does take an effort to transform. That's why I recommend starting at the smaller, more manageable scope than trying to boil the ocean upfront. But when you do that transformation, you will see significant acceleration, and then you can deploy that learning through the rest of the organization, and you can deploy it as a system, not just as a lipstick where you're like, hey, we're AI first using AI coding agents, where in reality you're just doing the same old things in the same old way with a little bit of AI assistance.
All right. Well, thank you very much for taking the time today to join me and share your insights and experiences around building agentic coding systems and some of the ways that the early engineering efforts have been obviated by the models and how we're in a constant loop of discovery. So I appreciate all the time and energy you're putting into helping to delineate the forefront and help move us forward. And I hope you enjoy the rest of your day.
Thank you. Thanks, Tobias.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.